So today we're going to study zeros of multiplicity 3. So for the graph, f of x is equal to negative x plus 4 bracket x minus 2 cubed. We're going to go and do this graphing scenario that we did from last day. Now, the first thing that we have to understand is we have to go and take a look at this thing called end behavior. Now, end behavior tells us that our function looks like something either near infinity or either near x is equal to infinity or to negative infinity, right? So now how do we get that for this function? If you take a look at the function f at x, which is in blue here, it actually turns into negative. Well, the negative comes from the front of this bracket for f of x that we have right here, right? That negative doesn't kind of go away, right? Now, the reason why we have x to the 4 is because when we do the expansion of this bracket here, there is an x from here, an x, and two x's from here that go and give this thing a fourth power. Sorry, this should be a 3. So it's fourth power. So if there is raised to the 3, you're going to get something raised to the 4, something raised to the 3, something raised to the 1, and you end up with something that looks like that. Negative x to the 4th as x goes to plus or minus infinity. And so now what we're going to do is we're going to study the symmetry of the function. So like we always do, we start with f of negative x. F of negative x. And we want to eventually get it to look like either negative f of x or just simply f of x. So now we'll substitute that negative in, and we end up with this, with the negative x minus 2 raised to the power of 3. So now, once we pull out from this bracket here a minus 1, it's going to cancel with this negative 1 here, so we end up with the following. So now we have x minus 4. Now, what about the other bracket? The other bracket, what we have to do is we have to actually do one extra step. We pull out a minus 1 from inside of the bracket, so you end up with x plus 2 all cubed. Now, that cubed is going to apply to this bracket and then this bracket here. Oh, sorry, not that bracket, the 1, the negative 1. So we end up with this. X minus 4 times x times minus 1 cubed times x plus 2 all cubed. Now, you know that negative 1 raised to an odd power will always be negative, so we end up with the following. X minus 4 and x plus 3 raised to the power of 3. So we have f of negative x is equal to this, which implies that this is not equal to f of x or negative f of x. So we can say that this function is neither odd nor even, which means there's no symmetry with respect to the x-axis or the y-axis. So now let's look at the intercepts. So our basic function can be written as y is equal to x minus 4, negative of x minus 4, x minus 2 cubed. So now we're going to do this. We're going to let x equals 0 to see if we can find the y-intercept. So let's do that right now. So we end up with, please make a correction to your equation. It should be plus 4 here. And then 0 minus 2 cubed, which turns into just this. Negative 4 times negative 8, which gives us y is equal to 32. So that means our point is going to be 0, 32. So I'm going to put a box around that so that we can use that later for when we're graphing. The next thing that we have to do is we have to go and calculate our y-intercept. So we let y equals 0 to find the x-intercept. So we have 0 is equal to negative of, let's see, x minus 4, no, x plus 4 times x minus 2 all cubed. So based on this, the zeros of our equation are x is equal to negative 4 and positive 2. So that means our actual points are negative 4, 0, and 2, 0 for our x-intercepts. Now, the x-intercept for 2, 0 and this one have different multiplicities. We will say the multiplicity of this one is 1, but the multiplicity of the 2, 0 is 3. And the reason why it's 3 is because the power that affects its factor up here is 3. So now let's take a moment and let's zoom out, and we'll take a look at our graph and all the information that we have for it. So we have all this information, and what we can do is we can graph it right. So when we do the graphing for this, we're not going to do it to scale because I can't figure out how to put 32 on this graph. So maybe this point here on my graph is going to be 0, 32. And for my x coordinate that touches the axis, this is going to be 2, 0. And our other point is also 2, 0. But then it's the other last point is negative 4, 0. So this is negative 4, 0. Now, before, because this parabola looks like x to 4, if it was x to the 4, the graph would have kind of looked like this and went up. But no, this is negative x to the 4. So the endpoints going towards infinity this way and down, our graph kind of looks like this. Coming in to 4, it does something, but we don't know what it's going to look like. So we'll need to go and use or calculate some additional points like we did before. So that was what we did with this portion of our calculation down here. So what we'll do is we'll calculate the extra points. So we have this. You'll notice that I pick points in between our x-intercepts and y-intercepts in order to see what's actually happening with our curve. So for this curve, we have a few additional points. So our two additional points are going to be 1, -1, and 2. And it shows us that our points look like this. So our first point is -181, and it's way up. The next point we have is 1, 5, which is way down here somewhere. The next point here is to be corrected. It's -2, 28. So our curve is kind of like this. So our curve kind of comes up, does this, goes up, comes back down. But as the graph comes down, as it approaches this thing here, this point here with multiplicity 3, what we have to do is we have to remember that our graph is supposed to kind of, with something that is x cubed, the graph kind of looks like either this, or it looks like, if it's negative x cubed, it kind of looks like this. So it's kind of like an S shape as it crosses the x-axis. So we actually have to make it look like that as it's crossing the x-axis, and then it follows down towards infinity. Now, the reason why this point here looks almost straight is because the multiplicity of this is 1, and any point that is multiplicity 1 has a straight line. And we're done. I guess we should also say that remember that the graph has to be upside down because it is negative x to the 4. And an even function has both values, either going up at the ends or both going down at the ends. And when I was talking about an even function, I was actually referring to this. That even function kind of looks like a parabola for now. Later on, we'll say it looks like a W. Now, for this problem, we're going to go through this really quickly. Let's take a look at the end behavior. The end behavior of this problem is this. Fx is going to turn into something that looks like x to the power of 6, which is an even function. So if it's even, this function has both ends that do this around as it goes away to, as the x values go to infinity. So it like sprouts up like so. Now, we can't necessarily say the same for our original function, so we actually have to test its symmetry. So let's do that. So you've got this for your basic equation. So we're going to follow that same pattern where we pulled out the -1 inside the bracket for every bracket. So we end up with negative of x plus 3. Then we have, when you pull out a negative from the squared bracket, you're just going to end up with -1 squared, which is nothing. It's just 1. And you still end up with, x plus 1 squared left over. Then we're going to pull out a 1 from this cubed part here. And you're going to notice that we're left with a -1, but when we cube it, we still have x minus 2. Now that -1 that we had here, I'm going to take that -1 and I'm going to combine it with this -1 in the front. And what that will do for us is it's going to give us this as our final answer. X plus 3 times x plus 1 squared times x plus x minus 2 cubed times x minus 2 cubed. And we're done. So here is our function, f of negative x. F of negative x is not equal to f of x, so therefore there's no symmetry with respect to the origin, I spelled origin wrong. Origin or the y-axis. So now when we're trying to find our y-intercept, this is what we have. We have to let x equals 0 and solve. And we end up with y is equal to -24. So that means our point is 0, -24 for our point. So I'm just going to make sure that I highlight that for later so that we can quickly find it. So now let's go through calculating the y-intercept, the x-intercept. So because of our original function, right, you've got x minus 3, x minus 1 squared, x plus 2 squared. The roots or the zeros are given as x is equal to 3, 1, and 2. The multiplicity of each of these are, well, for this one, it's 1. The second one, the number 1 here, its multiplicity is 2. And you'll see what that looks like. And the multiplicity for the minus 2 that we calculated before is 3. So based on that, we could easily go and graph this, but we need to know some extra points. So here's what we'll do. We'll get ourselves out of here. We'll set up all the points that we need for our graphing, and then we'll find some extra points on our graph. And so now here are our basic points. We have the point 0, 24, 0, -24, which is somewhere way down here. And this is at -24. And then we have 3 points which are on the x-axis, and they are 3, 0. We got 1, 0, and -2, 0. So let's plot those points. So here's 3, 0, here's 1, 0, and over here is, I'll call this -2, 0. So this is 3, this is 1, and then this is -2. So we've got all our points kind of labeled. So now we know that the endpoints that we talked about for our original graph are going to look something like this. They're coming in hot from way far away into our graph. Now, the multiplicity of the -2 is multiplicity 3. So what's supposed to happen is our graph comes in, and it's going to do kind of an S across the line. That's all you need to know. It makes an S across the line. The next thing we have to figure out is what's happening with the multiplicity of 1, which is happening here. For our point 1, it's multiplicity 1. So this graph is supposed to kind of look like a parabola opening up. So what's going to happen here is there's got to be some sort of point here in between 1 and 0. We could easily find that. And you'll notice that when you go and test all these other points, your graph actually comes down, goes back up, and then lightly touches 1 because it's multiplicity of 2. Think of it as like you've got like a parabola and it touches the x-axis. That's what's happening near that point. And then it comes down, but then it's got to go back up at some point and goes right back out. And that's it. Because remember, this one here, it looks like a line when you get really close to the 3. And this is multiplicity 1. So multiplicity 1s have a straight line going across. Multiplicity 3s have a kind of flat, have like a little flat dip as it crosses. Multiplicity 2 just barely touches and then forces itself to jump either up or continue straight down for the rest of infinity. And we have graphs just like this that we're going to be creating every day in our math class. And this is, remember, this is multiplicity 3. So just a quick recap before we go and do the work. So just a quick reminder, when we have a line that's actually interacting, we have our functions and it's got its exponents on it, what you want to think of is when the graph actually goes and touches the x-axis, right? What's going to happen for these different lines is for any odd function, the graph will kind of look like this. It comes down, it touches C in an S shape, or it goes this way in an S shape, one of those two. And then for this next one, if it is an even power that we have on our exponent, what's going to happen is we have something that looks like this. The graph literally comes down near the point and bounces back up. The same if the point is coming from underneath. And then finally, if we have something to the power 1 near the point C, what happens is our graph kind of looks like a straight line and continues on. I'm not saying that it looks like a straight line to us, but if we zoomed in on it, it would look like that. Now, here's your homework. So you're going to be doing these questions, page 138, number 27, 31, 33, 35, and 37. And if there's not a lot of time, we'll cut this down and you'll see on the worksheet what questions you have to do.